In number 2, we are to identify the one angle that is not coterminal with the others. And remember, coterminal just means that it starts and stops in the same place even though the measures are different. So since all of these angles are in radians, we're going to label our axes here with our our angles in radians. So we'll start at 0 at the positive x-axis, and that would put us at pi on the opposite side. So for 5 pi thirds, which is our first angle, we're going to mark off in thirds as we go. And for pi to be at 180, that means there have to be 3 pi thirds on the top. So we're going to cut the top into thirds. There's 1 pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds, 5 pi thirds. And then we're going to go to our negative 5 pi thirds. So switch a color here so you can see it as we count over. And then because now this is negative 5 pi thirds, we go in the clockwise direction. So this would be 1 pi third, 2 pi thirds, 3 pi thirds, 4 pi thirds, 5 pi thirds. So negative 5 pi thirds actually puts me back in the first quadrant. So one of these has to be our answer, but we'll keep going to figure out which one is the answer. 11 pi thirds, again we're going in the counterclockwise direction because the angle is positive, but to kind of speed things along, we can remember that once around the circle is 6 pi thirds, so then we can do 9 pi thirds across the top, and then this would be 10 pi thirds, 11 pi thirds, so this one is coterminal with the first one, which must mean that negative 5 pi thirds is not our angle. But let's see where these others put us, just to practice and get comfortable with this idea. So we're going to go negative 7 pi thirds, so we're going clockwise again. So that would be 1, 2, 3, 4, 5, 6, 7. And it puts me back where I started here. So this is negative 7 pi thirds. Now, the last angle is the one that you really need to work with to understand how this works. Because when you're taking a standardized test, this is a common question to see if you understand what we're learning in this lesson. So let's look at 365 pi thirds. Well, if you will recall that 2 pi is once around the circle, which we could update our circle to show that. Let me switch back to the gold color. It's a little easier to see on the screen. If we can get 6 pi thirds out of there, or I'm sorry, if we can get 2 pi divided into this big angle we have, we can see how much is left over, and that's what we'll be working with. Because remember, each lap around the circle really does nothing for our answer. So we want to get as many of those revolutions out as we can. In other words, we want to take away all the full revolutions from that angle. So the easiest way to do that when you're in thirds is to remember that there are 6 thirds in the 2 pi third, in 2 pi, so 6 pi thirds would be 2 pi. So I want to divide this by 2 pi in essence. So I'm going to say, well, that's equal to 365 pi over 3. And remember, if 2 pi is 6 pi thirds, which it is, that means when I reciprocate this and multiply, I'm going to have a 3 on the top and a 6 pi on the bottom. Well, the nice thing here is that the pi's cancel, the 3's cancel, and leave me with 365 over 6. Well, if I can get 6 into the 360, which I can, I know that that's going to be 60 with a remainder of 5, 6. Now normally I'm not a big fan of mixed numbers, but this is one place where they work out nicely because I can throw the 60 out, because basically what that would mean is that if we took the tracing the circle approach, we'd go 1, 2, 3, 4, and so on, 60 times to get us down to 5/6 of a revolution. So then if you're trying to figure out where you're going to end up, simply that's 5/6 of a full circle, which would be 5/6 times 2 pi. So again, I can stick a 1 under that. The 2 cancels that down to a 3, so that gives me 5 pi thirds. So analytically, we have demonstrated that this angle would also be coterminal with the others we've marked so far. And negative 5 pi thirds is the one that is not coterminal. Then we look at number 6, and we are to evaluate the 6 trig functions for this picture that they gave us, that I've sketched here. So that's not really a big problem, because this is where we use a reference triangle that would be established by the point they've given us. And I'm going to draw it and then kind of shade it in here for you to make it jump out. Here's our reference triangle. So we come down here to our workspace and we draw the reference triangle. And the more you draw the triangles oriented the way you see them in the picture, the more it'll help you think about what you're dealing with. For the point 3, -5, that would make our horizontal move, which would be our adjacent to our angle at the origin. And that looks more like a dot than a theta. I'll make it a little bigger. Okay, so at theta at the origin, 3 is my adjacent and -5 is my opposite. So we need to figure out what our hypotenuse is. So we do the positive values, because when we square them it wouldn't matter whether they were negative or not. 3 squared plus 5 squared equals c squared. Then that would be 9 plus 25, which is 34, is c squared. Means that if I take the square root of both sides, our hypotenuse is the square root of 34. So then I use my SOHCAHTOA memory trick to know where each ratio comes from. So we start with sine, and the sine of theta is opposite over hypotenuse, and the opposite would be -5. The hypotenuse would be the square root of 34. The cosine is adjacent over hypotenuse, so we would put 3 over the square root of 34. And then the tangent is opposite over adjacent, and the opposite is -5, the adjacent is 3, and then we write their reciprocal relationships beside them, and the reciprocal of sine is cosecant theta. So I just flip the answer I got, keep the sign the same, SIGN. So since sine is negative, this cosecant, its reciprocal, will also be negative. So that's going to be negative square root of 34 over 5. And then the reciprocal of cosine is secant theta, which is positive. So we're going to have positive secant, because that's the reciprocal of cosine, and that's the square root of 34 over 3. And then finally cotangent, which is the reciprocal of tangent, and so I just reciprocate my answer there, which was negative, so this one is also negative, and that is -3/5, and we're finished with number 6. Number 8 is basically the same question, but they didn't give us a picture this time. So we're going to draw a picture to help us see where this triangle would sit. And I like to just completely convert all of my thinking about trig to triangles. Some students don't agree with that, but I feel like if the triangles confuse you, then using the angles outside of triangles is probably not going to be much better. So I'll leave that up to you. But I'm going to draw a triangle based on the fact that my point is at -4, -6. So I go 4 to the left, 6 down, puts me here. And remember, we always draw a line connecting the point back to the origin, so then the triangle is established relative to the x-axis, and here's my reference triangle. So then I can label it directly where it sits. This is -4, and even though geometrically these would not be negative, it's great for our purposes to keep everything with the same sign it came in with from the coordinates. And so then again we need our hypotenuse, so we do 4 squared plus 6 squared equals c squared. 4 squared is 16, 6 squared is 36, and added together that would give us 52. So 52 equals c squared means that c equals, because 52 is divisible by 4, I can take the square root of the 4 and get 2, and that would leave 13 inside the radical. So our hypotenuse here is, and I'll switch colors so you can read it on top of the blue there, our hypotenuse length on this one is going to be 2 on the square root of 13. So now we are ready to list our 6 trig ratios. So the first one is sine, and sine is opposite over hypotenuse, and the opposite here is negative 6. The hypotenuse is 2 on the square root of 13. And remember, you can leave the radical on the bottom, but you do need to reduce your fraction here. So this is negative 3, if I can make a 3, negative 3 over the square root of 13. Cosine is adjacent over hypotenuse, and so the adjacent side would be the negative 4 over 2 square roots of 13, which is equal to negative 2 over 2. I'm sorry, I'm losing my mind again. Hang on. If I reduce by 2, the top becomes negative 2, the 2 goes away on the bottom, leaves me negative 2 over the square root of 13 for my cosine, and then the tangent, which is opposite over adjacent, and from the origin, the opposite side would be negative 6, the adjacent would be negative 4, and the negatives will cancel and give me 3 over 2 to make tangent positive as it should be, and it should be the only one of the 3 that's positive in that quadrant. So then we're going to get the reciprocals, which we just get directly from our first 3 answers. The reciprocal of sine is cosecant, and the cosecant of theta is going to be negative square root of 13 over 3. If sine is negative, so will cosecant be. Then our secant of theta, which is the reciprocal of cosine, will be negative as well because our cosine is. So it's negative square root of 13 over 2. And then our cotangent, which is the reciprocal of cotangent, will be positive because of the fact that its reciprocal was positive. And that's number 8. Number 10. Negative 3, 0 is on the terminal side of an angle. Find all 6 trig functions. And I sort of abbreviated the instructions here just to jump us right into it. So here we go. Might be helpful to see the picture. And again, you can treat this one of 2 ways, either using what you know about the unit circle, which I tend to do, or you can draw a triangle every time. And I'm going to switch and make this point blue to make it kind of pop at you. And there it is. So that's the point, negative 3, 0. So now we're going to, but just to reinforce what you are doing in this lesson, we will go with the author's plan here, which is for you to use the definition of the trig functions or the trig ratios for any size angle. So remember the sine, excuse me, the sine of this angle is going to be y over r, and r is just the distance from the origin, so r for this problem is going to be 3. So our sine, which is the y coordinate, is 0, and our r is 3, so obviously our sine is 0. Our cosine, which is x over r, and our x coordinate was negative 3, goes over the positive 3 for the r, which gives us negative 1. And you'll notice that these 2 values correspond with the x and y coordinate of the unit circle. And then we have the tangent of this angle. Tangent is y over x, so that is 0 over negative 3, which is 0. Then to get the 3, doesn't really require much thought other than just pairing them properly. The reciprocal of sine is cosecant, and the reciprocal of 0 would be technically 3 over 0, but it is undefined because the 0 would go to the denominator. And you can abbreviate it UND, and I'm okay with that. Alright, and then the reciprocal of cosine will be secant theta, and that would be the reciprocal of cosine, and negative 1 is its own reciprocal, so the secant and the cosine are the same in this case. And then our cotangent, which would be the reciprocal of tangent, and again tangent 0, so if I flip that, 0 is going to the denominator, so that makes our cotangent undefined as well. And that's the end of this example video.